All right, hello everybody. I hope that you are all doing well today. My name is Natalia and I am an educator with the Cincinnati Observatory. So today we are going to be getting in some imaginary spaceships and we're going to go fly out into outer space and look at some pretty cool stuff. And so today we are using something called Mitaka, which is a computer app that helps you look at stuff in outer space. And in case after watching this video you are interested in downloading Mitaka for yourself, it is spelled M-I-T-A-K-A. But let's go ahead and get started. So go and take a seat in your imaginary spaceship and let's go. All right, so say goodbye to our home planet for now. We will be back eventually. And as you can see, we have gotten to our very first orbit in outer space. So this is the moon orbiting around us, and every single little line that you see that is in a circle like this in Mitaka represents one thing in space orbiting around something else in space. So keep that in mind. And now we are moving out to the center of the solar system. And so in the middle we have the sun, and the sun is the only star inside of our solar system. And then we have the 8 planets. So we've got Mercury, Venus, Earth, Mars, and then in between the inner and outer planets we have all of these teeny tiny little dots right here. What do you think all those teeny tiny little dots are? At first glance, you might be tempted to call those stars. However, remember, we are still inside of our solar system, which means there is only one star, the sun. So all of these little dots that you're seeing are asteroids. This is the asteroid belt. And so the asteroid belt sits right in between Mars and Jupiter, and we have about 800,000 asteroids inside of our solar system. But we're going to keep moving past those. And something that you might notice while we are in Mitaka is that Mitaka will tell you how far you are away from the sun as you go through space. And so here we have gotten to our very first unit of measure. It says 1 AU as soon as you get next to Earth, and 1 AU is 1 astronomical unit. And so I think a lot of people are familiar with the term light years as the way that you measure while you are in outer space. However, when you are in the inner part of the solar system, miles is a little too small, but light years is a little too big. And so in between those two units of measure, you have AU. And 1 AU is the distance from the sun to the Earth. But let's keep going. All right, so we've got Jupiter, Saturn, and as you can see, once we get out to Saturn, we are already 10 AU out. And then we've got Uranus and Neptune, and then all of a sudden, we go from having all of these really nice, even-looking orbits to having these orbits that are kind of strangely shaped. They're not as even. Look at Sedna's. That's really crazy. And so this is how you know that you have gotten out to the dwarf planets. And so I think a lot of people know that dwarf planets are typically smaller than regular planets. And while this is true, this is not the most significant difference between dwarf planets and regular planets. So really what makes the difference is the orbit. And so regular planets like Earth and Saturn and Jupiter, they can all clear their own orbital path. And what this means is that if while Earth is going around the sun, a big giant asteroid gets in the way, Earth is strong enough to either push that asteroid out of the way or pull that asteroid into its orbit. Now, Pluto and the other dwarf planets are not able to do this. They are not able to clear their orbital paths. And so because of this, they are classified as dwarf planets, and they end up with these orbits that are very strangely shaped, and instead of being like these that do not intersect at all, they intersect in multiple different places with other orbits. And so you can see here, Pluto intersects with Neptune's orbit a few times, and so sometimes it's even closer to the sun than Neptune is. It also intersects with some of these other dwarf planets' orbits, and that's how you can tell that it is a dwarf planet instead of a regular planet. But let's keep moving, and now we are about 1,000 AU out. And we are in a place called the Oort Cloud. So the Oort Cloud is at the very outside edge of the solar system. So we are still inside of the solar system technically. And we see all of these teeny tiny little dots. What do you think all these teeny tiny little dots are? If you guessed comets, you are correct. And so again, it might be tempting to look at these and think that they are stars, but there is only one star in our solar system, and that is the sun. And so we see all of these little comets. We don't know exactly how many comets there are inside of the solar system because they're kind of small compared to planets, and they're at the outside edge of the solar system. That makes it pretty hard for us to count exactly how many there are, but there are probably a lot. So as you can see here, we are finally outside of our solar system. We are 3 light years out. And so if our solar system is just this little tiny bright dot, what do you think all these other little bright dots are that you are seeing? If you guessed stars, you are correct. So finally, all of these little dots that you're seeing are other stars that we're passing up, and even other solar systems, since a lot of stars have planets going around them. And then we have reached our galaxy, the Milky Way Galaxy. And so as you can see, we are actually pretty far out in the Milky Way. We are not close to the center at all. This is us right here, and here's the center of the galaxy. So it's pretty big, and it has billions and billions of stars in it. But we're going to keep moving past that. Now we are 10 million light years out, and you can see the Milky Way Galaxy is just a teeny tiny little dot in the background. So if the Milky Way Galaxy is just a teeny tiny little dot, what do you think all these other teeny tiny little dots are? They are other galaxies. And so we're passing up all these other galaxies. They're projected to be between 100 and 200 billion galaxies in the entire universe. And then this is everything. So this is the outside edge of the universe, and it looks kind of strange. It almost looks like its own little planet. And the reason for that is that a lot of scientists think that gravity pulls the outside edges of the universe into kind of a spherical shape. So it looks a little strange, but everything that we have discovered or theorized to exist fits within about 13.8 billion light years, any direction that you go away from Earth. Now, does that mean that this is actually everything? Probably not. There's probably still a lot of stuff that we have not discovered yet, but this is everything that we know about right now. And so what we are going to do is we are going to put our spaceship on super speed and zoom back into our teeny tiny little home planet. So we're passing up all this different stuff that we talked about, and then there we are. We are back to our home planet. And so thank you so much for hanging out with us today and watching this video. We're going to be putting up some more videos of us going through and looking at some stuff in space in Mitaka, so keep your eye out for those. If you are interested in some of the other stuff that the Cincinnati Observatory is doing, check out our website at cincinnatiobservatory.org. Have a good day.